Welcome to the video lecture for section 4.6, Newton's method. Newton's method is a technique used to approximate the solution to an equation f of x equals 0. Newton's method uses tangent lines of the graph of y equals f of x near the points where f equals 0. So the idea is that you progressively get closer and closer to this point using the derivative. So the idea is if this is the first guess for x naught, then we can slowly move in by using the tangent lines to move x closer and closer and closer to the actual root we're looking for. And so the function for this, the idea is you guess a first approximation to the solution of the equation f of x equals 0, and you can use a graph to help. For example, and we call this number x naught. We use the first approximation then to get a second approximation, the second to get a third, and so on, using the formula x sub n plus 1 equals x sub n minus f of x sub n over f prime of x sub n. So let's use Newton's method to find an approximation for the negative fourth root of 2 by solving the equation x to the fourth equals 0. Okay, so to do this, start off. So we've got the function f of x equals x to the fourth minus 2, and we can go ahead and find f prime of x. So f prime of x is going to be 4x cubed. So 4x cubed. And so we can start out by graphing the original function. So if I graph the original function, so let's clear out what we were using from the last section. So y equals x to the fourth minus 2. And if we zoom in here, we can see, let's do the negative one, sorry, over here. We can see that this value falls between negative 0.5 and negative 1. So for the negative fourth root. So we can pick a value on either side of that. So let's just start with negative 1. So if I let x naught equal negative 1, then x sub 1 is going to be x naught minus f of x naught divided by f prime of x naught. So in this case, that would be negative 1 minus negative 1 to the fourth minus 2 over 4 times negative 1 to the third. Okay, so if you want, you can use a calculator to find that value. So negative 1 minus negative 1 to the fourth minus 2 over 4 times negative 1 to the third. Okay, and so we get negative 1.25. Okay, so then to find x sub 2, we do the same thing except with x sub 1. So it'd be x sub 1 minus f of x sub 1 over f prime of x sub 1. So in this case, that'd be negative 1.25 minus negative 1.25 to the fourth minus 2 over 4 times negative 1.25 to the third. Okay, and once again, we can use the calculator for this. And to ease ourselves, we can double-click on the last answer to bring it down here, and then we can just add the 0.25 to all of my negative ones. Or if you prefer, you can type the whole thing out again. And so that's negative 1.25 1935. And you would continue on like this. So x sub 3 would be negative 1.1935 minus f of minus negative 1.1935 to the fourth minus 2 over 4 times negative 1.1935 to the third. And each time we do this, we come a little bit closer to the actual value of the function. So we go back in here. I can double click on this one. And in fact, I think if I erase this and I double click on my last answer, yeah, it'll substitute it in there. So if I get rid of the value and double click on my last answer, it'll substitute it in there. Okay. And so for that one, we get negative 1.18923. And so now we're getting really close. Negative 1.18923. We're getting closer and closer to the real value. So then let's do one more. So then x to the fourth would be negative 1.18923 minus negative 1.18923 to the fourth minus 2 over 4 times negative 1.18923 to the third. So I can do the same thing I just did, grab my last function, get rid of the x values, and use the double click function to substitute in my new x values from the last problem. And so when we hit enter, we get negative 1.18921. So so that's negative 1.18921. And so we've gotten very close to a good approximation of what this looks like. And if we go back to the original graph that we did, and we, sorry, I got rid of it, or the calculator might have gotten rid of it for me. And we click on this x value, see it's negative 1.18921. Is its approximation. So we got a good approximation for this using Newton's method. So that's what Newton's method is for, finding approximations. So why don't you guys flip over to the next page, and all it wants you to do is it wants you to use Newton's method to approximate the real zeros of the following functions. Find x sub 0, x sub 1, and x sub 2. So just do this basically twice. Start with x sub 0 and use Newton methods for each one twice. So go ahead and pause the video. Use a graph to find a good approximation for x sub 0, and then do this method for both of these. And once you're done, we'll go. You can unpause the video and we'll go through them. Okay, so let's go ahead and look at these. So I'm going to start by graphing them. All right, so we've got y equals x cubed plus 3x plus 1. Okay, and then I'll go ahead and graph the other one while I'm at it. So y equals 2x minus x squared plus 1. Okay, so if we zoom in, for this, we can see that both of them have a root on the left-hand side that's between negative 0.5 and 0. So you can get one, and this one over here is close to, is between 2.5 and 2 for the second one. So good x sub zeros, you know, you could use any value, but you could start with something to the left of the one here. So you could use negative 1, you could use negative 0.5, you could use 0. Those are all good values. I think for both of these, I'll start with an x sub 0 equal to 0 in one example. And for the second one, I have 2 zeros. So I need to pick 2 values. So for this one, I think I'll also use 2. You could use 2.5. You could use other values to start out with. So this one I'm going to have two different ones to find the two different. And so that's where I'm going to start out. So for this first one, x sub 0 is 0. So x sub 1 is 0 minus f of 0 over f prime of 0. So f prime of x is 3x squared plus 3. So this would be 0 minus f of 0. So that's 0 cubed plus 3 times 0 plus 1 over 3 times 0 squared plus 3. So that's negative 1/3. Okay, and then I can plug that in to find x sub 2. So x sub 2 is going to be negative 1/3 minus f of negative 1/3 over f prime of negative 1/3. So that's negative 1/3 minus negative 1/3 cubed plus 3 times negative 1/3 plus 1 over 3 times negative 1/3 squared plus 3. And so we probably want to use a calculator for that. So negative 1 divided by 3 minus negative 1/3 cubed plus 3 times negative 1/3 plus 1 over 3 times negative 1 divided by 3 squared plus 3. And we get negative 3.222222. So a bunch of 2's. So this is negative 0.3222. Okay, and that's all. And if you kept going, you could get a slightly better approximation. So then we can do the same thing over for these. F prime of x, in this case, would be 2 minus 2x. So this will be x of 1 will equal 0 minus 2 times 0 minus 0 squared plus 1 over 2 minus 2 times 0. So that's negative 1/2. And so then x of 2 is negative 1/2 minus 2 times negative 1/2 minus negative 1/2 squared plus 1 over 2 minus 2 times negative 1/2. So that's, let's see, negative 1 minus a quarter. So negative 1, those are 0. Negative 1/4. 2 minus negative 1 is 3. So it's like negative 1/2 minus 1/12. Well, let's go ahead and just plug it in to make sure I get it right. So negative 1 divided by 2 minus 2 times negative 1 divided by 2 minus negative 1 divided by 2 squared plus 1 over 2 minus 2 times negative 1 divided by 2. And that's negative, we could do it as a fraction, probably negative 5/12. Okay? And then we can do the same thing with 2, right? So x sub 1 would be 2 minus 2 times 2 minus 2 squared plus 1 over 2 minus 2 times 2. So that's 1 over negative 2. So that's 2 plus 1/2. So that's 5/2. And then we could do the same thing with 5/2. So 5/2 minus 2 times 5/2 minus 5/2 squared plus 1 over 2 minus 2 times 5/2. And so I'll use the calculator for that because that's a little more complicated. I'll just plug my answers in here. And that's 2.4126, which if I wanted to, I could do as a fraction too, which is 29/12. Okay, so that's the idea of Newton's method. So each time you do it, you get a little bit closer to the actual answer. And that's it for section 4.6. So I hope you enjoyed this video. As always, make sure you're checking my math lab for the due dates of assignments. And I will be sending out reminders about virtual office hours. And also remember, you can always contact me by email or by phone or text.